Acid-base neutralization is a part of our everyday lives, from impacting us by treating our bastings to treating our basic or acidic soils. Neutralization reactions are important because they occur in almost every bodily function, like maintaining the proper pH for values for our enzymes to function correctly and making the stomach acidic enough to break down the food we eat. An acid-base reaction is a type of neutralization reaction in which an acid reacts with a base in order to yield a salt plus water. A common example of this is when hydrochloric acid, HCl, reacts with sodium hydroxide, NaOH, in order to yield sodium chloride, NaCl, plus water. Sodium chloride is commonly referred to as salt, as table salt, but it is not the only salt to exist. A salt is an ionic compound in which the anion is neither an oxide ion nor a hydroxide ion. The definition of a salt is any chemical compound formed between an acid and a base, with all or part of the hydrogen of an acid replaced by a metal or the anion of the base. If we look at an example of an acid-base reaction, we can easily neutralize it using our formula, knowing that an acid plus a base yields a salt plus water. Write the reaction when a solution of hydrofluoric acid reacts with potassium hydroxide. This reaction will give us a salt where the anion of the acid is replaced with the other metal. This will give us potassium fluoride plus the hydrogen and the hydroxide of the acid and the base will give us our water. This equation is already balanced, so let's look at another example. Write the reaction when a solution of sulfurous acid, H2SO3, reacts with sodium hydroxide, NaOH. The salt formed will give us the sodium and the sulfite of each. However, if we look at our charges, we can see that the sulfite carries a -2 charge, while the sodium carries a +1. So, in order to balance this, you will need 2 sodium ions for every 1 sulfite. So the sodium will need a subscript of 2 plus our water. However, as you can see, our entire equation is unbalanced, so we will need to add coefficients. We will need a coefficient of 2 in front of our sodium hydroxide and a coefficient of 2 in front of our water. Now, our balanced equation is H2SO3 plus 2 NaOH yielding Na2SO3 plus 2 H2O. Now our equation is entirely balanced and fully neutralized.